Eternity can break down the main contributing factors of slowness in business activities to better direct your troubleshooting efforts. When the network is identified as the main bottleneck, we need key network metrics and metadata to zoom into the root cause of performance issues. In the case of a managed network, such as an enterprise MPLS or WEN, Classic Network Performance Management, or NPM, can provide great insight. Classic NPM, such as the one powered by App Response, relies on packet collection directly from your managed network, for example, using spans or taps from your infrastructure devices. NPM can extract valuable insight from network packets with the help of technologies such as deep packet inspection, which can quickly point to the root cause of network issues. However, modern hybrid applications rely on a combination of managed and unmanaged infrastructure, where classic NPM faces limitations. For example, home office users typically access cloud services through their internet provider, connect to enterprise applications via VPN, and their traffic is encrypted due to zero-trust policy enforcements. So Classic NPM has little or no visibility into their network performance. Riverbed NPM Plus complements Classic NPM by enabling packet collection at your managed endpoints and overcoming all these gaps in network performance visibility. NPM Plus is part of the powerful Riverbed Unified Agent, which provides enhanced extensibility and modularity to the collection of digital experience data at your endpoints, while simplifying deployment, maintenance, and agent updates. To find out more about the Riverbed Unified Agent, click on the on-screen link. Now, let's see the NPM Plus dashboards in action in two common scenarios.
John, Thomas, and Tim are collaborating remotely on a big presentation using Microsoft 365, and their deadline is fast approaching. While Thomas and Tim's applications perform well, John's apps are slower than molasses in the winter, putting the team's deliverables at risk. The help desk quickly identifies slow network response from John's device by looking at his troubleshoot user experience dashboard in Eternity. With NPM Plus, the help desk can drill down even further and find out why the network is underperforming. This is the NPM Plus Analyze Users dashboard. First, let's set the specific timeframe of poor performance reported by John. By default, this dashboard will display network throughput details, but we'll want to switch our view to the response time composition chart to further break down John's application's response time on the network. The response time composition chart, or RTCC, is a powerful visual that helps zoom into key metrics that point to potential causes of delay. Now, let's filter this view to only see John's traffic and its performance. And to analyze the performance of his applications individually, let's set the breakdown to applications. While John has reported that multiple Microsoft 365 applications are slow, they do have a common element: OneDrive file collaboration activities. Indeed, we can tell Microsoft OneDrive has longer network-related delays than other applications. But why? Let's review a timeline of these delays with the help of our RTCC by filtering only traffic from John's device to OneDrive. We can see here well over an hour of consistently slow response time using OneDrive. That looks painful. Request data transfer times remain especially high, indicating long delays simply exchanging packets over the network. Let's now review network performance from a new angle: latency. By switching our view to focus on round-trip time, we can analyze the impact of network latency in application and network performance, and whether anything changed lately. Indeed, at around the same time John started seeing issues, his connections to OneDrive saw a jump from around 50 milliseconds in round-trip time to around 400 milliseconds in average. Latency plays a huge role in the performance of several types of applications, especially so in file syncing operations, which can be very chatty. Now, let's compare John's round-trip time performance to that of his teammates by including their usernames to the dashboard filter. Yep, it looks like John's latency might be playing a significant role on his OneDrive performance, since Tim and Thomas's measured round-trip times are well within expected levels. Since we now have strong indicators of a potential trouble area, let's now look at a custom analyzed dashboard for more targeted investigation. This dashboard allows full control of all breakdowns in every view, which helps us isolate potential causes of issues even further. First, let's switch the measurement category to round trip time. Now, let's set up our breakdowns and filters to review a key factor in home office performance: VPN gateway usage. We know that all enterprise VPN gateways contain the string GW, so we can search for this string in our service name filters. What's this? John's home office is located in the US, but he seems to be connecting to a VPN gateway located halfway across the world. This is clearly the cause of longer round-trip times, as evidenced in our dashboard. The network team reviews this information and finds that John's username had erroneously been placed into the group which connects to the Israel gateway, and then corrects the group configuration. John's performance is now back to normal, and his team can meet their deadline with ease.
In this demo, we will look at the case of Barbara Roberts, who relies heavily on the Cloud Suite SaaS application to process customer orders at her job. Barbara has been experiencing significant slowdowns while using Cloud Suite, which in turn could cause shipping delays and lead to customer frustration. Attempting to complete a series of critical orders, Barbara drove back from her employer's corporate branch to her home office, hoping that app performance would improve in a different location. Unfortunately, Cloud Suite remained very slow at home throughout the day, which prompted Barbara to call the help desk to assist. The next day, Barbara was connected with the network operations team, who specializes in network performance analysis. They had deployed extensive app response monitoring throughout the corporate network, which provided great insight into application performance, but had no visibility on Barbara's traffic when she was on her home network. Fortunately, the help desk had installed the Riverbed Unified Agent with NPM Plus in Barbara's laptop, which expanded visibility of her performance regardless of her location, as well as any other factors such as zero-trust encryption or VPN tunneling. Starting analysis in the Eternity Troubleshoot User NPM Plus dashboard is as easy as searching for her username and clicking on Go. The Troubleshoot User dashboard provides immediate visibility into critical metrics and related information. We can break down the performance of each of Barbara's applications and their network utilization, as well as analyze response time over time, along with likely causes of delays, with the help of our trusty RTCC. After setting the time frame to when Barbara's Cloud Suite issues were reported, let's review some key performance and usage metrics. The IP activity table helps visualize the usage level of all applications that use the network on Barbara's laptop, which can help identify anomalies in usage, such as traffic peaks or even resource hogs. While we could easily focus our view to only look at Cloud Suite performance with the help of our top filters, let's first analyze all applications to see our possible approaches. Further down this dashboard, we can find the TCP Performance panel, which lists all detected applications and reports on their key performance indicators. We can focus this view on any of the major components of delay we would find in the RTCC: connection setup, payload and data transfer, round trip, and server response times. In this case, server response time is notably higher and the largest component of delay for the Cloud Suite application, especially when comparing to the response time of other applications. However, this table provides the average value across the entire day. Was server response the only slow element? Are any other network components, or even the user's location, a factor in poor performance? Let's find out. First, let's change our table breakdown from application to interfaces. This is a great way to separate the performance from Barbara's home office location from the corporate branch performance. By clicking on each interface, we can analyze the performance of Cloud Suite at home or at the corporate branch. Now, let's click on Cloud Suite to focus the rest of our dashboard, and let's take a look at the response time composition chart for yesterday. Server response time remains the primary bottleneck from the corporate branch location. Now, let's perform the same analysis while focusing on the Global Protect VPN interface that Barbara uses from her home office. Looks like server response time remained high all day, and we can appreciate there is no significant difference between locations in overall delays or contributing factors of slowness. The fact remains, throughout the day and in various locations, server response time is consistently the biggest bottleneck and the cause for Cloud Suite's slowness. Time to approach the application team with this information so they can work on a solution for Barbara. Thank you for viewing this demo. To find out more about NPM Plus, click on the on-screen link.